All right. So yesterday we looked at the trend setters problem. Okay. So this was one of the behavior diagrams that we created earlier that describes the general process. So like this is an activity diagram. So it describes the steps and branching or parallel execution of steps. Okay. And then we created, yesterday we created a class diagram, right? Based on our understanding. Okay. And now we're gonna try to create a sequence diagram for the most important functions here. So if we're gonna create a sequence diagram, so this trend setters by location is the main class, or the central class that has the main code, okay, the main access point to the system. All right, so now we need to choose which functions need to be, which function is worthy of creating sequence diagram for. Not everybody, like, we don't need to create a sequence diagram for every single function. Something like set location, for example. Do we need to create a sequence diagram for that? It just takes a location and set it. So it's really self-explanatory. So we don't need a diagram to explain it. Okay. So if we are gonna need a diagram, we probably need the diagram though for the find trending topics, because that's the central function, and it has several steps that involve interaction with other objects. So that is a good function to have to create an interaction diagram for, or we're talking about sequence diagram here. Okay. So if you remember, a sequence diagram has objects with lifelines. Now, again, if you don't have it open, you can add it from here, from software, and then UML sequence. Now, almost every other tool have some form of a sequence diagram. Okay, now let me start here. So we need an object. So let's say our main object, it has to be something of type trend setters by location, right? So I can specify a name or not. What really matters is the name of the class. So the trend setters by location is the name of the class. Now this column in front of it means that this is an object of that type. Now I can have a name for it or not, doesn't matter yet. Okay, so if I put something here, so that would be the name of the object if it really matters. Okay, so let's say we're gonna need a caller, someone to call. So assume that we don't need an actor, so an actor would be something on an external source. But let's say what we're gonna start the operation in a function called main. Okay, so we can create a function called main outside of the trend setter location, and then call the first function from there. Okay, so we're gonna have arrows coming out of outside like this, indicating messages coming from the main function. Okay, now just remember that the direction, the vertical direction means time. So time goes like this down. Okay, I'm just gonna draw an arrow to indicate that. No, I don't wanna, okay, if I create a connector like this. So this is not a message, okay? This is just a general arrow, just to let you know that time, no, it's gonna keep. This is the direction of time. Okay. Maybe I get the arrow from the, no, but no, we don't have an arrow here. So this is the direction of time. Okay. The vertical direction, it doesn't really matter. I mean, the order of the objects in the on the horizontal dimension doesn't matter. So it doesn't matter whether this object comes first, like is put first, or it doesn't matter which object is first in terms of the horizontal dimension. What really matters is the vertical dimension, that is the time. Okay. Now there's a function call that we need to indicate here. So when a function is called, it creates a frame for that function, right? So that frame of that function is represented on the diagram by the activation frame. Okay, so there's a call that is gonna come to this function, to this object, asking for the execution of a function. Now remember, the message passing in object-oriented is just a function call, but through the object. Okay, so in the main function, we're just gonna create an object of this type and call this function on it. So the function that we are looking for is find trending topics. Okay. And everything, pretty much everything interested in would happen within that frame, right? So that frame should span for a long time here, because there is a lot of calls and a lot of actions that happen inside of it. Okay. All right. So what happens? So now looking back at our class diagram, so what should be done in terms of just message passing and objects? Okay, we don't put the details of the implementation in a sequence diagram. If anything, you want to put the details, the steps of the executions, you can create an activity diagram for it. Okay, now here we just need function calls and interactions with objects, including self objects, like self calls. So, okay, so what happens inside this find trending topics based on the functions that we have defined here? Can everybody see? So what should I do? What should I say? What should be the first step? What should be the first call, function call? Yeah. Yes. Okay, we can start with set location self call. Okay. Set location. I mean, this could be would be better sent for in the function here, right? So we see as we go, we start finding better ways to define our functions. So now, if okay, we set location might make sense, but it might be easier if we just send it as an argument here, right? So as we go, we can define our diagram. So I can define this and say location here, and then call the set location based on that to adjust the shared variable that is called location. Okay, and it would be good if I go back and make sure that the diagrams are all updated. Okay, so now finding topics, we realize that it would be better if it receives the location here. Okay, we saw the location. What happens next? Now see how the structure diagram doesn't indicate any sequence of actions? Even though, like, when we thought about it yesterday, we thought about set of functions. We probably, when we were thinking, we had some sequence in mind, but the sequence is not represented in this diagram. That's why we need a a dynamic diagram with it. Okay, so we have the topic. We need to find the trending. We need to find the trend setters, right? So now we have the topics. Oh, sorry. Okay, my bad. Maybe that's why you're confused. So finding the topics itself is one of the steps, and then find trend setters per topic is the pretty much where all the action is. Yeah, maybe that's why you were confused. Sorry about that. That's my bad. So here. So finding the topic is just going to update the topics. All right. And the topics, we decided that it's going to be a shared variable here called topics so that everybody can access. All right. Now, what else? We need to send another message to execute the function that finds the trend setters, right? But we'll find the trend setters per topic, right? So there's a call. Now, are we gonna create the loop outside and keep calling the find trend setters per topic? Like this? It is possible, but it's not good. It's not good encapsulation. So encapsulation means like everything that operates on the topics should be within the class. Okay, so here's another refinement that we can do for our design that we created in the class diagram here. We would want to have a function that would be called outside that is called find trending topics, trend setters, that doesn't take anything, and that trend setter, this function will loop over all the topics that we know here and call the one that takes the topic. Okay, so that would be a better encapsulation for the topic. Okay, so I'm just gonna call find trend setters, the one that we just added to the class diagram that doesn't take any arguments, and then it starts a loop over the topics. And inside that loop, all the action happens. So I'm just gonna take, there's a loop fragment here. Now, depending on the tool that you're using, you may or may not find something like this, but at least you find that like something like a node, something like something generic that you can add a loop to it. So at least you find something that like this, a generic fragment that allows you to add some nodes or add some context to the diagram.